Right, so for this one, the answer is high density. Yeah, right. So why is that? Okay, if you look at this formula, pressure equals to density H times G. Okay, now so density, okay, is the one that we manipulated variable. Okay, because we have two types. Okay, ataupun two mediums. We have mercury and water. Mercury has higher density, water has lower density. Okay, so now from this formula, so this formula is obtained from here, yeah. Okay, pressure in liquids. Okay, pressure equals to H def. This one is rho, bukan P. Rho, it means density, and G is the gravitational acceleration. The gravitational strength. Okay, now from this formula, rearrange the formula so that we have H, the depth, is equals to the pressure per density and gravitational acceleration. Now, what's the relationship between density and depth? Once we have mercury, that means pressure density is high. So when we have high density, density has inverse proportional to depth. So when density high, the depth needed low. Right. So let's say this is the barometer. So this is the depth. This is the only depth ataupun the only length of the tube we need when we use density. What if we have water? Now, from this formula again, if we have lower density, that's here, we need higher depth. So, imagine if we have the barometer, so that length is not enough. That length is not enough. Jadi we need longer. So if I draw it next to this one, so if this is the depth with mercury, so we need higher length to fulfill this one, higher depth. So this one, the depth will be longer. So if we need longer tube for the barometer, so that means this is not feasible, not okay lah. It's very hard for us to mobilize the barometer. Okay, so that's the reason. Okay, alright. That's why we need high density, or that's why we use mercury usually. Based on diagram 1, state the atmospheric pressure in the unit of centimeter Hg. So here, you see the unit centimeter Hg. So kat sini kita tengok lah. So there are so many units can be used for this, for pressure, physical quantity pressure. So state the atmospheric pressure. We look at this. So it's this measure atmosphere, and here it's vacuum. So since this is vacuum inside, no air particles, therefore this represents the atmospheric pressure. Force, push, so this is the pressure. Okay, so because of that, the mercury rise up and up to this level. So we have 76 centimeter Hg. As simple as that. Okay, the next question, calculate the atmospheric pressure in the unit of Pascal. So what's the difference between these two questions? So it's just the unit. So this one, the same physical quantity. This one, physical quantity, the question wants atmospheric pressure. So that's the physical quantity. Number 2, also the same physical quantity, which is the pressure, atmospheric pressure. But the unit is different. So from here, how to convert to this unit. So that's about the question. So we know formula, pressure equals to rho Hg. 1.36, just add, substitute, kg per meter cubic. Okay, this one is the trick. You need meter. But this one is centimeter. So we want to remove this centi. But we cannot just remove like that. And we need to know that centi is equals to 1 centi equals to 1 times 10 to the power negative 2. So we have 76 centimeter Hg2. But we change this one centi. So centi tadi 10 to the power negative 2. The unit is meter now. And G is 9.81 Newton per kg. Okay, so you just use for a calculator and you get the answer, which is 1.01396 times 10 to the power 5 Pascal. Okay, make sure you write all these numbers because they are all meaningful. They are. This is actually the value. 1, 2, 3, 4, 5. So the value is actually 101396 Pascal. You have to write all these numbers. Okay. Let's say maksudnya kat sini kan, kalau let's say kita ada jual beli. Okay, this is the price. Your cost. But I just pay you 101,000 and I took the 369 from you, right? So this is quite an amount. Dia bukan sikit, dia banyak. Jadi semua ni bermaksud you have to write all the numbers. It's not like this. Let's say this one 1.01396 times 10 to the power negative 12. If this negative 12, actually 0.0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 0.1396. So if this is the case, so this one, not even 1, Jadi, so you can just write it like this, 1.101 times 10 to the power negative 12. So this is okay. But for this one, you cannot simply write as ni kalau student tinggalkan 1.01 times 10 to the power of 5 Pascal. So this is wrong. Sebab value dekat belakang ni important. Right? Okay, number 2. Diagram 2.1 shows the reading of a Borden gauge before the piston of a bicycle pump is pushed inwards. Diagram 2.2 shows the reading of the same Borden gauge when the piston of the bicycle pump is pushed inwards. So, ni adalah soalan tentang Borden gauge. So, Borden gauge, what is the function? Okay, to measure Borden gauge, to measure pressure, gas pressure. Okay. Based on diagram 2.1, tick the correct answer in the box Borden gauge can measure. Okay, of course, the answer is gas pressure. Okay. Next. Observe. This one is a kind of this is an easy question. Just look at the diagram and compare. So that's not difficult. Compare the volume of air inside the bicycle pump. So you just look at this. So here is the 0. So this one, if let's say lah, this is 1, 2, this is 3, and this one, since this one 0, 1, 2. So that's obvious. This one, diagram 2.2, pressure higher. 2.1, pressure lower. So, okay, and then before that, the question asks you about volume. So, where's the gas? So, look at that. The gas for 2.1, here. Here are all the gas. But 2.2. So what's the answer? So kita tahu. So if let's say you want to write 2.1 first, volume of gas inside diagram 2.1 is more. Yes, more. Or you can just use symbol more than in diagram 2.2. Yeah. Okay. Right. Next. Compare the pressure produced. So that's obvious tadi. So pressure 2.1 is less. So your answer, pressure in diagram 2.1 less than that in diagram 2.2. Just make sure write 2.1 first, and then compare the number of air particles inside the bicycle pump. Okay, what do you think? So this is the same pump, the same pump. So if the same pump, so the number of particles should be the same. So the answer, you can just answer C for both. Based on the answer, state the relationship between volume and pressure. So this is volume, so that's pressure. So the higher the volume, the less the pressure. The higher the volume of gas, the lower the pressure. State the physics law involved. What's the law? So this is okay, what's the relation? Okay, topic gas. Okay, kita ada PVT. So this one is not gas actually. Ini topic heat ya. Salah. Ini dalam topic heat actually ya. This is topic heat. So we have volume and pressure. So that's boils. Law. Okay. Next, diagram 3 shows a log floats at the surface of a river water. Name one force that is acting on the log. Okay, this one is about Archimedes principle. Okay, what is Archimedes principle? It says that an object that is fully or partially immersed in a fluid will experience a buoyant force. Which is equal to the weight of water displaced. Okay. So kat sini keywordnya fully or partially. What happened? Immerse. Immerse in gas. Maybe it immerse in water. Maybe in a liquid. Anything, any fluid lah. Fluid means can be liquid or gas. Anything yang mengalir lah. So it experiences a buoyant force, and that buoyant force is equal to the weight of water displaced. Okay, so that's about Archimedes. So this one is floating. So bila dia floating, this one is about Archimedes principle. So the forces acting are first the weight. Okay, and then buoyant force. So buoyant force, this one dekat atas, lifting it. Okay, name one force. So either one lah. Okay, it can be weight. Okay, so or you can write buoyant force. Next, give one reason why the log floats. Okay, so you need to know when object is floating, it's because the buoyant force is equal to the weight. The weight weight ni dia tampung the buoyant force, ataupun the buoyant force menampung the weight. So dia tak ke atas, dia tak ke bawah, dia tak sinking, dia tak accelerating upward. Jadi the answer will be, it's because weight, jadi dalam gambar tu kan nampak, is equal to the buoyant force. Alright, so ni key thing you kena tahu. Anything that is floating, the weight is equal to the buoyant force. Now, see, the mass of the log is 1200 kg and the density of the river water, okay, is 1000 kg per meter cubic. Calculate the volume of water displaced by the log. So, kat sini, you need to know a formula. Yes, okay. So, this is the formula. Okay, so ni okay, tadi kita tahu buoyant force is equal to the weight. Okay, and then we have another formula. This is not formula, this is an equation you should know. When it's floating, when an object is floating. Now, any buoyant force ataupun the buoyant force for an object when it is floating, buoyant force is equal to density times volume times G. So, for this one, you should know that formula. So, rho Vg. Okay. So, density of the liquid, volume of the liquid. Sebab the liquid holds the water. The water holds the log. So, we take the density of the water, volume of the water, the liquid, volume of the liquid displaced. So density, what's the density? 1000 kg per meter cubic. The volume is the one that we want. So V, G is 9.81 Newton per kg. Okay, and buoyant force. Do we know buoyant force? So what's the buoyant force? Okay. So actually the buoyant force equals to, tadilah konsep tadi ni, this one here, weight. So do we know the weight of the log? Ni. Okay. Kita tahu weight equals to mass times G. Okay. So what's the mass? Mass is 1200 kg. What's G? G is 9.81 Newton per kg. Okay, sama, potong, cancel out. Therefore, volume equals to, so the volume equals to 1, you just use your calculator, dapatlah cubic. Okay, boleh? Kita tahu ni. And then kita tahu ni. Then we substitute. using this formula. What happens to the volume of water displaced when the log floats in sea water? So instead of a river, now we have sea. What do you know about sea or river? Okay, so for sea, density higher. This one, density lower. So we cakap decreases. Okay, why? Okay, just now we know the weight of floating object is equals to the buoyant force. And that is equals to density of the liquid times volume times G, rho Vg tadi. So dekat sini, what's the relationship between between volume and the FB, the buoyant force? Okay, density and G. Okay. Density of seawater higher. So it's higher. So what happened to the volume then? So it is inversely proportional. So bila dia inversely proportional, dapat berapa? Okay, dia volume decreases. Hence the answer. Okay.